Okay, now let's talk about how to do some cleanup work uh, on the data we collected using FSMO. So this is a file, the spreadsheet created by the FSMO, and then I opened it using Excel. If you don't have Excel at home, you can actually use a Google Drive. There's a spreadsheet. You can work on it. It's very similar. Uh, Okay, so when you open this file, you normally just see the default trace, but if you tried a couple of traces, you should see, a list of file here. And then I actually just want to save this, so I just copy. So I'm going to work on this one. Okay, you can see on this data we have too many information, like the frame. We don't actually need this, so I'm going to delete this column. And then this X and Y, those are the pixels. I don't need them too. So I just go ahead, delete them. And then the last two, the Y coordinate, is a little bit up and down when you mark the position. It doesn't really matter. Okay, so only worry about the horizontal displacement. Okay, so that's why we did that too as well. Okay, now that leaves only the time and then the position, x, the horizontal position. Okay, so we're gonna need that, and then scroll down at the end. The last 4 frames, actually, I didn't record the data because it was invisible. The edge of the glider is just went to the far right side, so I can't see them. Okay, so then I clean up. I have 36 it should be, because the first one is just the title. Okay, that's the data I need for the time and the position. And also I need to create the velocity. So I'm gonna put it here, velocity. It's supposed to be the average velocity. The unit should be meter per second, right? Okay, then I just make it wider a little bit. You can see this is the velocity. You have to find the time interval. So if we look at these 2 frames, the time interval should be using the 0.025, subtract this 0.016667 second. Okay, so and then that's the delta t, right? And then the delta x would be using this position, subtract this position, right? Okay, uh, so that's why I'm just gonna make it equal. Okay, something wrong. I have to. Okay, do it again. Equal, and then I put a bracket, and then click this one, then subtract this one. Okay, so this will calculate the displacement. Divide by, and then I click this time, subtract this time. Okay, you have to click, and then in this bracket is going to be the time, right? So the A3 really means the cell on the column A, and then the row number 3. Okay, so of course A2 refers to this cell. Okay, that will calculate the average velocity between the first 2 frames. So I enter. Okay, that's gonna be the velocity I got. And because this velocity is the average velocity between these 2 times, so what is the time, when this velocity happens? Of course, it's average velocity. The time should be between these 2 times. But I'm gonna use this velocity to approximately to to represent the velocity, the instantaneous velocity at a time, and at what time it's going to be the time in the middle of this two. Okay, so I'm just gonna make this equal, and then add this to time. So the A2, A3 refers to this two cells. So I just added this to time, and then divided by 2. So that way we can find out the time in the middle of this two. Okay, now this is going to be the time in the middle of this two frame, and then this average velocity, I can treat it as the instantaneous velocity at this time. Okay, and then I just simply copy everything. So select these two, and you can click or just click this, copy. Okay, click, and then just select all this cells, all this area that you need to paste, and then just click paste. Okay, and then each of them is gonna do exactly the same calculation. You can click this and you check the formula right here, so that's gonna be right. Okay, now I just created the data, these two columns, that's the data generated using FISMO. These two columns are the velocity time data that's actually calculated using these two columns. And then we're gonna transfer this data into another software called GeoGebra, and to actually find the graph and then find out the acceleration.